completing the square. So this is completing the square. What we're going to look at is how to solve quadratic equations by taking square roots. But if you're going to solve an equation by taking square roots, you need something that is a perfect square. Sometimes you do already have something that's a perfect square, other times you don't. When you don't have something that's a perfect square, you're going to use a process called completing the square to create a perfect square so that you may solve the quadratic. So when we talked about solving quadratics before, we said solve when y equals 0. In this case, you can see there is no y to worry about. We just need to solve for x. So this is an example where we're going to get x by itself, then take a square root to solve. So part A, I'm going to subtract 5 from each side. I get 3x squared is 15. Then I am going to divide by 3. I get x squared is 5. So then I take a square root to finish solving. I get x is, but when we do this we have to say plus or minus the square root of 5. Because if I know that x squared is 5, I'm not sure if it means the positive square root of 5 or the negative square root of 5, which we had mentioned before. If I tell you that a squared is 16, a could be 4 because 4 squared is 16, or a could be negative 4 because negative 4 squared is positive 16. So when you solve an equation by taking square roots, you have to have the plus or minus when you take the square root. In part A, I could write this as square root of 5 or negative square root of 5. So then try part B on your own. In part B, we get 8x squared is 32 when we add 3 to both sides. Divide each side by 8, we get x squared is 4. So then you take the square root of both sides, you get plus or minus the square root of 4. So x is 2 or negative 2. Which, just as a little note for when you're doing homework in Math Excel, it's kind of annoying that sometimes you have to answer the way they want you to, but sometimes you have to answer the way they want. Thank you. The way they want you to. They say to separate your answers by commas. So in Math Excel, you would write that 2 comma negative 2. Again, it's annoying to have to answer it the way they ask you to, but they do specify to just write your answers that way. And in part B, the answer would be 2 or negative 2. In this problem, we have to remember the formula for area of a circle. What is the formula for area of a circle? Area is pi r squared. How many circles are there in the problem? 3. So 3 times the area is 3 pi r squared is 500 centimeters squared. To find the approximate radius of each circle, we would divide each side by 3 pi. We get that r squared is 500 over 3 pi. So r, in this case, should we worry about taking the positive and negative square root?
No.
Why not?
You can't have negative.
Because we're dealing with a length here, and we don't need to worry about negative length, so we just take the positive square root of 500 over 3 pi, which is approximately what? Round to the nearest thousandth for me. Okay, to put this in the calculator, what you want to do, if you have the old operating system on the calculator, it'll give you square root with a parentheses. And in that parentheses, you want to do 500 divided by, and then in parentheses, you need 3 pi. And then you can close the parentheses for the square root, for the radical.
Where were we running to?
Nearest thousandth.
284.
7.284. And what are my units on that, Mr. Govea? Centimeters. Centimeters. 7.284 centimeters, with this symbol here meaning approximately, because that is a rounded number, it's an approximation. Here, this is an example that illustrates the goal of completing the square. Because in this case, we do not have to complete the square. In this equation, on the left-hand side, we already have what we defined earlier as a perfect square trinomial. Because that is a trinomial that factors as, in this case, it's going to be x plus 6 times x plus 6. The right-hand side doesn't change, it is still 9. So the left-hand side we can write as x plus 6 squared equals 9. So now when we solve this, we can take the square root on each side and we can get that x plus 6 equals plus or minus the square root of 9, which is plus or minus 3. Which in this case, we have to realize that means x plus 6 could equal 3, or x plus 6 could equal negative 3, and the best way to finish the problem is to just write those two separate equations. X plus 6 could equal 3, or x plus 6 could equal negative 3. Solve each of those, subtract 6 from each side, we get x is negative 3, or x is negative 9. You need to have, to do this, the left side needs to be a perfect square trinomial, and you need to have a leading coefficient of 1. That leading coefficient cannot be anything other than 1. And again, this was an example where we did not have to complete the square because there was already a square there. Here, we have x squared plus 14x. I want to add something or subtract something. I need to do something here so that I can rewrite whatever quadratic I get as x something squared. When you are completing the square, if you think about this in standard form, a has to be 1. In this case, b is 14. And we are adding c. In order to have a perfect square trinomial for this process, we need a to be 1. B is just going to be something. B is going to be some number. To complete the square, C has to be B over 2 squared. So in this problem, that is 14 over 2 squared. So just like we said, this should be plus 49. And if we have x squared plus 14x plus 49, that factors as x plus 7 squared. Which we can check by taking x plus 7 times x plus 7, and foiling it, we get x squared plus 7x plus 7x plus 49, which is x squared plus 14x plus 49. So this is what we get from completing the square. We complete this expression to be a perfect square trinomial so that it factors thusly. And as another note, when you do this process, this factored form, it's going to be x plus this number right here is always going to be b over 2. To solve this problem, the first thing, to solve using completing the square, the first thing we have to remember is what I said about the leading coefficient. What did I say about the leading coefficient? The leading coefficient must be 1. So I'm going to divide the entire equation by 3, which is going to leave me with x squared plus 6x minus 1 equals 0. So we have this quadratic, and to use completing the square, we don't want this, right? We notice this is not a perfect square trinomial. So actually what we're going to do is we're going to say x squared plus 6x equals 1. We add this 1 to each side. So now we have this empty space where we can complete the square. And what should we do here to ensure that this side is a perfect square trinomial? So we leave that space to complete the square, and here b over 2 squared is 6 over 2 squared, which is 9. And if I add 9 to the left, I must also add 9 to the right to keep things balanced. So then on the left, this factors as x plus 3 squared. The right side is 10. What do I do at that point? So again, we complete the square so that all we have to do to solve is take a square root. And when we take the square root of each side here, it is going to be plus or minus the square root of 10. To finish solving for x, what we get, we subtract 3 from each side, so negative 3 plus or minus the square root of 10. Which, to make that clear, that is negative 3 plus square root 10, or negative 3 minus square root 10. So the y-intercept graphically, if I have a parabola, the y-intercept is just where it crosses the y-axis. That's the graphical idea of a y-intercept. So in this problem, it's probably easiest to start by finding the y-intercept. What do we know algebraically if we're on the y-axis? Do we know what the y value is? No, because they're asking for it. So we don't already know it. But what do we know about the value of x if we're on the y-axis? X should be equal to 0 for the y-intercept. So when you do this in standard form, yeah, it's 0 squared minus 10 times 0 plus 4. So the y-intercept is 4, which is the point 0, 4. So finding the y-intercept is the easiest thing to do first in this problem. Then we are going to rewrite it in vertex form by completing the square. So we have y equals x squared minus 10x plus 4. To rewrite that in vertex form by completing the square, we get y equals x squared minus 10x, and I'm going to move the plus 4 out here so that I can complete the square there. I don't move the 4 to the other side because in vertex form it has to be y equals. There cannot be anything over here except for a y. So, what do I put here to complete the square? We do b, which is negative 10, b over 2 squared. Negative 10 over 2 is negative 5. You square that, you get plus 25. But I have to keep my equation balanced, so what do I do? I cannot add it to the left side because I want the left side to remain y. So what can I do to the right side to keep things balanced? I added 25. Now subtract 25. Do that here. So what's the point? The point is I can now look at this part, right? That part I can rewrite as x minus 5 squared. I can then look at this part. That is minus 21, which I will trace over that in white so you can actually see it. Minus 21, and voila, we have the vertex form. So we have the y-intercept, we have the vertex form. The last thing, name the vertex. What is my vertex? Vertex is 5, negative 21. Questions there? Vertex form is y equals a times x minus h squared plus k. Mr. Cannon.
Just find the vertex first, too.
You could have, yeah. But if you're going to be finding vertex form anyway, you might as well just find vertex form because it'll be easier to find the vertex from that than it is from standard form.
Can you just check it like that?
This one. We want to write this one in vertex form. Can anybody see why I want to do this example as well as the previous one? In this example, my A is not 1, which creates a little bit different thought process we have to go through. For one step. One step is a little bit different. Everything else is the same. So to rewrite this in vertex form, I'm going to say 3x squared plus 18x minus 3. I'm going to take these first two terms and I'm going to lump them together here. That minus 3 here, just kick to the curb. We don't care about them right now. And we want to complete the square in here. To complete the square, what must we have for A? 1. So we have to, in that big set of parentheses, factor out a 3. So we get x squared plus 6x. That minus 3 we kick to the curb is still out on the curb, hasn't changed. So now we want to complete the square in those parentheses. How do we complete the square in there? So now we have to add 9 in this set of parentheses. So this is the part of the problem where things get a little bit different. How do I keep the equation balanced? Again, understanding that I don't want to do anything to the left side of the equation. I want to do something here that's basically going to undo my plus 9. Since I add 9 here, you just have to realize that I added 9 in this set of parentheses, which is multiplied by 3. So by putting a plus 9 here, I've actually added 27 to this side of the equation. So to keep things balanced, I must subtract 27. So then my vertex form is 3 times x plus 3 squared minus 30. So my vertex is negative 3, negative 30. So that is why I wanted to work through this example, is that when I add 9, if you've had to factor something out, you've had to change a to be 1, then adding 9 here is actually adding 27 to this side of the equation in total. So to keep it balanced, since I add 27 here, I must subtract 27 over there.